Hello, everybody, and welcome back to I Wish You Were Dead, a podcast about things that used to be alive. My name is Mike, and our expert over there is Gavin. Gavin, how you feeling?
I'm doing pretty good, Mike. Feeling refreshed after my nice sort of week off last week.
Yes, your week off, which consisted of listening to me talk about baseball players and murder, which is right up my alley, and hopefully it was up yours too.
I did. I really enjoyed it. I really did. Really did. It was a nice break, and also learning lots of new things about a baseball, a sport that I sort of like marginally enjoy. But also my local area, which is really nice.
Yeah, all of it was fun. I like whenever I get the opportunity, I like being able to throw just a little something to the podcast that you contribute so much to on a weekly basis.
Absolutely. So I guess let's get into some announcements.
Yeah.
Just nothing major today, just the typical, we have a Twitter, please follow it. I've been retweeting lots of really good open source sort of articles. So if you want to learn more about science, and if you have any kind of question, see any of the things that we retweet and have questions, feel free to like DM the Twitter account or on the retweet, ask some questions. I'd be more than happy to either try and answer them as best as I can, or I know, or at least am aware of, you know how you have like sort of weird Twitter friendships where you keep interacting with the same people, but like you've never met them or never actually talked to them.
Back when my Twitter account was public, I remember this.
Mm-hmm.
Ever since I became a public school teacher, that has been locked down.
That's fair. Um, but yeah, so like I have that with that sort of weird relationship with several relatively well-known Twitter scientists. So I feel like I could tag somebody who would know more about it than I would. And the whole point of Twitter is for people like that to be able to answer questions about, it might even be their own research. So definitely check us out on Twitter at dead podcast underscore. So I've been having a lot of fun reading it and going through a lot of these articles myself. So
I've been checking out some of those links, and even though many of them are above my head, they are still quite a lot of fun to check out and listen to.
yeah, absolutely. And unless you have any other announcements.
Other than again, just in the description, we've got those forums where you can take a look at. You can either request a topic or say you want to be a guest on an episode. I know that somebody just recently filled out one of those forms to be a guest on a future episode, and that's something that we are going to try and get set up moving forward with number one fan of the Podfia. But
Absolutely.
that is about all I have going on right now. So if we want to take a look at today in science,
Absolutely. So do you have a year for me, Mike?
it's been going back the last couple weeks. I'm gonna say this reverses the trend, and we're gonna be up to 2018.
Oh, you were so close. 2017. You had the right idea, but overshot a little bit.
I'll take what I can get.
So this is from June 28th, 2017. No evidence found of human lifespan limit.
I I have some questions, but continue.
Again, this is the only one that was even vaguely in my wheelhouse, so we're rolling with it. But it goes on to read, geneticists from McGill University in Montreal, Canada, surveyed the longest-lived individuals from the United States, the United Kingdom, France, and Japan in an attempt to determine the maximum potential lifespan of humans. Though the extensive research included individuals from every year dating back to 1968, that doesn't seem like that long ago.
I was gonna say like we can do better than like
Scientists
Lyndon Johnson was president. I get that was a while ago, but it wasn't that long ago.
It goes on to say scientists concluded that no meaningful evidence existed to suggest that the existence of any upper limit. Researchers believe that if such a limit exists, it has neither been identified nor reached.
So basically, there is no reason human beings couldn't live indefinitely, is what these researchers are saying, or at the very least, whatever limit exists has not yet been found.
I think that there might be something just very poorly worded about the way this paragraph is written, which kind of tracks with how this calendar's gone thus far.
Yeah, so far.
I think what they meant with the whole 1968 thing was looking at records of old people who were old in 1968, not like
Uh,
born in 1968. Because
oh,
like my
oh,
dad was born in 1969, so
my dad
like
was born in 1962, so like,
yeah, so like that's not old.
yeah,
I
my
I
dad's old, but he's not that old.
I think that that's what they're meant, but is not at all clear. I so how aging kind of works, at least to my limited understanding. I've taken two genetics classes that talked about this a little bit, but essentially every time your cells replicate, anytime they replace themselves, they go through the process of mitosis, which I feel like most people have at least heard of, even if you don't really understand how it works. But it's basically when your cell duplicates all the different organelles and things inside of it, and then splits itself from one cell into two. And that is how your body sort of repairs itself generally. When that happens, they also have to replicate your chromosomes, which is where your DNA is held. And when they do that, there are these things at the end of your chromosomes called telomeres. And
Hmm.
the best sort of analogy that I've heard is that they're sort of like the aglets of your shoelaces, the little plastic things at the end.
Right?
They,
Yes, I am familiar with this. Yeah, and that's kind of what keeps it
mhm.
from. Isn't correct me if I'm wrong, but like as those little the aglets at the end of your chromosomes get worn down, that's sort of how aging happens. Is the little protective parts go away?
Not necessarily go away, but their structure sort of just, every time if you were to like copy paste, like an image in like an image editing software or something like that, um, eventually it would start losing some of its quality. And it's essentially like that. If you just copy it over and over again, it will
Right.
just naturally, there will be an error in there somewhere. And then that error in one of, the one cell becomes two. So if there's an error in one of them, that one cell is then going to eventually split into two. Then those two are going to split into four. So that's how it can kind of spread. That's also generally sort of how cancer works with some kind of mutation like that.
Hmm.
Um, Obviously not quite the same as the telomeres not copying correctly, but generally that's how cancer works. Uh, so that's to my knowledge how I always kind of learned that aging worked. I would be very surprised if there was not an upper limit. That would surprise me very much.
Right. I mean, it's one. I don't know enough about any of this, but like I think of jellyfish as something that gets cited as something that would live indefinitely. You know, unless something unless a predator eats it or something.
So
But
there is one species of jellyfish that doesn't just live forever. So it doesn't just like exist until something, cuts it in half or something eats it or something. What it does is when it encounters a stressful situation. So this isn't even like it'll just do it if it's living a happy life, it'll live forever. No, it has to like have some kind of a few specific kinds of stress. And I actually listened to this like the more details about it on a podcast not all that long ago, and I forget which one it is, but hopefully I'll remember and we'll put it in the show notes. But it was under certain kinds of stress, it would revert back to its like larval stage. It would basically Benjamin Button itself
that's a thing that can happen.
in this one single species of jellyfish, apparently. And it happened by accident as well. I think they had them in the tank studying them for something else. And I don't know if they like forgot to feed them or something went weird with their water chemistry. And they looked and they were like, where are the jellyfish? And when they looked closer, there were a bunch of larvae in there. And or what's called polyps, or what sort of larval jellyfish are called. And so there were a bunch of those floating around. And so they sort of did it again, and it happened again. And so there's one specific species of jellyfish that can do that. It has been hypothesized that others might be able to do it, as well as a couple other different types of invertebrates. Vertebrates are much too complicated for that kind of thing to happen. Um, I vertebrates are very very complicated organisms, and
Right. There
so
seems like there's quite a lot of points of failure.
exactly, and so it would, like I said, it would just very much surprise me if there were not some kind of upper limit onto how old at least humans can get. Some other things, like tortoises, you know, they also get old and eventually just die of old age. What makes them live so much longer than us? I don't actually know. I'm sure that there is a pretty good working, explanation for that, but off the top of my
Hmm.
head, I don't know. Um, but yeah, I don't know how much I buy that.
Agreed. And with all of that, I think we can just go ahead and move right on to our topic of the day. So, Gavin, what is it that we are going to be learning about today?
Today, we are going to be talking about pterosaurs, everyone's favorite flying reptiles.
Pterosaur.
Not not the only flying reptiles, because remember, as we've talked about before, birds are reptiles.
Yes.
But when you think of flying reptile, this is what you are thinking of. And so in episode 21, we talked about how flight evolved and how it works. And in the four different groups of animals that have evolved flight, which are insects, birds. Actually, there's kind of an asterisk on that because there's been some recent evidence coming out that dinosaurs evolved to flight more than once.
What?
Yeah, like there are some potentially flying non-bird dinosaurs. Weird. We can talk about that at a different time.
I am looking forward to that.
But yeah, so the the ones that we have the best evidence for are insects, birds, bats, and pterosaurs. And so today we're going to be talking about pterosaurs in particular. A, because one, they're super neat and one of the coolest groups of organisms, in the entire fossil record, in my opinion. But also, why we're doing this specifically today has a little bit of just sort of me memeing a little bit. So, as Mike and I have talked about a bit, we both volunteer for an organization called HOBie, which is the Hugh O'Brien Youth Leadership Seminars. And so, basically, long story short, we bring a bunch of high school sophomores in a normal year, a local college or university, and train them how to use their leadership skills to make positive changes in their communities. Obviously, this year, it happened over Zoom. And so Mike and I volunteer for the one based out of Central New York. I also volunteer for the one based out of Maryland and the one based out of Western Pennsylvania. During the Western Pennsylvania one, I don't know who. Actually, I know who. I don't know where he got it from. Presumably some kind of summer camp thing. A lot of people involved in Hobie also do things at summer camps. But for legal reasons, when some of the students go to like the bathroom or really go anywhere without an adult in the room, we make them take a buddy, the buddy system. And so,
as you do, yeah, this is a very common practice.
right. And so, 15, 16-year-olds don't like being told, hey, for insurance reasons, bring a buddy. That they tend to not, that doesn't encourage them to actually do it. However, what one particular person at Hobie, Pennsylvania West started doing with some of his groups was telling them that, quote, pterodactyls would come and get you if you're alone. You need to take friends to fend off pterodactyls from coming in and swooping down and carrying you off. And then that just became a thing. Anytime that there was something that like our insurance won't let us do, like for example, we can't really do any sport associated things or any really athletic things at Hobie. And then he turns that into the pterodactyls will come get you. If you are doing sports, they like the activity, they think it makes you look delicious, and they will come take you.
My God, I am stealing that. Because I run a summer camp. It started just on Monday, just a couple of days ago. We have the buddy system for us. I am stealing that.
Absolutely, it's so good.
I'm threatening my children with being eaten by a dinosaur. Oh my God,
they're not dinosaurs, Mike.
Yes, yes, we discussed this.
But which we will talk about. We will talk about that throughout this episode.
I'm laughing so hard to think about stuff. This is awesome.
So that is why I'm doing this in particular, so that I can shamelessly plug it in our. So we actually have a Slack channel for the seminar, and we actually have a thread in it called Pterodactyl, which is just for the staff to meme and post jokes and stuff like that. And so I'm going to shamelessly post this in that thread, being like, "Please watch my podcast or listen to my podcast, please, thank you."
Hello, Hobie, PA West. It's nice to finally meet you guys. I've heard so many things about you.
So, but there are many things wrong with that statement, which we will break down throughout this episode. So,
I'm usually, when you say things like, I'm usually like, oh, I'm looking forward to it. I'm not looking forward to this one, actually. I would prefer not knowing why it's wrong.
Oh, no, you're going to learn.
Okay.
So the first one is just the word pterodactyl.
Yes.
So that is technically correct for only one species.
Okay.
So the correct term, and hopefully the term that Mike puts in the title, is pterosaur.
Pterosaur.
Yes. So pterosaur means wing lizard. Even though they're not lizards, but as we talked about, that's just sort of the suffix that gets put on any extinct reptile. And then pterodactyl means wing hand, both of which, like I said, are varying degrees of correct. But the reason why they're called pterodactyls is because the first genus to be described is called Pterodactylus. It was the first one found, and so that's the one that kind of stuck. Sort of as we talked about with mastodons. Mastodon is not actually like a real term. When we talked about that in the elephant episode, it's not really a real term, but it's the one that caught on. And so pterodactyl only refers to one species that wasn't particularly big. We'll talk about a bit about how big it is to begin with. But so that's just sort of that first sort of clearing up some confusion. So let's talk about these animals themselves a little bit. So pterosaurs are one of my favorite examples of saying, just because something is extinct doesn't mean that it went extinct because it was bad at doing what it was doing. Sometimes survival of the fittest, natural selection doesn't necessarily just mean, okay, things that are worse at doing something are now extinct. That's not always what that means. Because pterosaurs were around from about 230 million years ago to 66 million years ago. They were around for just under 200 million years. They had a really good run.
That's quite a long time.
Mm-hmm. So they show up first in sort of the middle to late Triassic period. And they go extinct when, at the same time, the non-bird dinosaurs did at the end of the Cretaceous period, 66 million years ago.
Okay.
So that's sort of when they're around. And let's talk about something that pterosaurs are very famous these days for, which are their size. So for reference, the largest flying bird that I was able to find record of had a wingspan of about 23 feet, around 7 meters. Pterosaurs ranged in size from about 10 inches, relatively small, to up to 35 feet, some estimates a little over 40 feet.
Is like the 10-inch one, are those like the baby pterosaurs?
Nope, those would be just different species of, full-grown adults. Some of the earliest ones, yeah.
Wow, so the range on this is from 10 inches up to possibly 40 feet?
Yes.
Oh my God,
and
that is absurd.
That is wingspan. Some of the biggest ones, when they were not flying, so when they were on the ground, they would be approximately the size and shape of a giraffe, but with a head almost about as long as its neck.
Wow.
Picture that in your mind.
That's right. That's a picture.
Pterosaurs have been found on every continent, including Antarctica, which is notable.
You took the question out of my mouth.
And there's been total about 100 different species described. So this is not at all a group that, didn't do well. They did extremely well, were extremely diverse in their time, and the dice just happened to not fall their way, as sometimes happens in nature. So that's sort of some of just like the statistical things, the quick stats, the things you might see on the back of its like playing card or something.
Right.
So let's talk about a bit about their anatomy before we get into some of the actual diversity and some of their evolution.
Okay.
Because as we talked about with elephants, they're just very strange. They're extremely strange. Uh,
Nothing's gonna beat that elephant episode. I'm sorry. That was
this one might give it a run, realistically.
okay.
So, pterosaurs. They were the first vertebrate group. So, obviously, insects had been flying for a fair amount of time before this. But pterosaurs were the first vertebrate group to develop flight. And they were by no means the worst. By some estimates, and again, this is mostly speculating because we don't have any around today, they were likely better and more efficient at flying than birds are.
Better, and what does it mean to be better at flying or more efficient? Like just using less energy per flap per, distance
Like per
crossed.
per distance traveled usually
Okay.
is how I see that sort of. But and so the smaller ones probably were just as agile as some of the most agile birds as well. They could,
Oh,
turn on a dime. They could, catch stuff in midair. One particular example, which we'll talk about, had a very special way of catching things in the air.
wow.
But yeah, so some of their anatomy, so their wing structure. So they are really unique compared to birds and bats. And this is just going to be a recap of some things that I talked about in episode 21, talking about flight. But so pterosaurs, they lose their pinky finger, but they make up for it by making their ring finger very, very, very long.
So they just do not have, a fifth finger,
No, they do
but
not.
their fourth finger is just super incredibly long.
Absolutely.
This sounds
Uh,
like bats, if I remember correctly. You're talking about that in the flight episode.
so bats, what they do is they make all of their fingers, except for their thumb, very long. So they sort of do the
Oh,
opposite. Pterosaurs make one finger real long and keep the rest short, and bats make or keep one finger short and make the rest long.
gotcha. Okay.
So pterosaurs, they stretch their ring finger several feet away from their hand, and then stretch a big flap of skin from the end of that to typically most of the time their foot, sometimes their hip area. Um, and there are different parts of it. There's the main flap that goes, like I said, from the end of the ring finger down to the lower part of the body. That is called the brachiopatagium. And
Okay.
a patagium is just sort of a word for a flap of skin, like a flying squirrel. The flap that they have between their arm and leg that they use to
Yes.
glide from tree to tree. That's also called a patagium.
Mm-hmm.
They have one from like their wrist to their shoulder in front of the arm called the propatagium. And they had one between their legs. Some of the earlier ones had one that sort of connected it at the ankles, connected their legs. That one's called I don't remember if I actually said it, but that's called the uropatagium. And then some of the later ones had sort of a separate one that was sort of split down the middle on each leg. And so they were basically just a kite.
I'm hearing patagium, and like, what's the etymology of patagium? Like, what does that mean just on its own?
I don't actually know, to be
Okay.
honest. I wish that I did, but I do not.
It,
Um,
I will live. I just heard that in
mhm.
each of these names, so I was curious.
Right, that's just a general word that means flap of skin. I don't
Gotcha.
know what the origin of that is, but
Mm-hmm.
uh, so that is sort of how their wings are made up. They have a really interesting bone, and one of their defining characteristics is that they grew an extra bone in their wrist. So birds, we've sort of talked about bat wings already, where they just kind of make all of their fingers really long. Birds fuse up. They drop the pinky and the ring finger, and then just fuse up all the bones in their pointer and middle finger.
Mm-hmm.
Uh, but pterosaurs, they grow an extra bone that points from the wrist back to the shoulder that supports that propatagium, the one from the wrist to the shoulder, sort of in the front of the arm. So they have an extra bone in their wrist that supports that and provides that with like them an extra way to control that and control their wing shape. And that is
Okay. Yeah.
that is a big thing with anything that flies, is controlling their wing shape. Birds do it by just moving their feathers around. You know, they have little muscles attached to basically every feather that can subtly change their feathers and the way that their wing is shaped, to provide, you know, more lift, or just to make it smoother, to reduce drag, or to create more drag if they're landing or something. Um, or if you've ever sat on like the window seat on a plane, as the plane flies, you can see the different parts sort of shift around and change the wing shape. Same thing.
That is, I remember the first time I saw that and I was like, oh my God, we're going to crash. And no, it's supposed to do that.
Exactly. Just because, you know, as you're doing different things in the air, you want to change the shape of your wing to make it better for whatever you're doing. But that bone is unique to pterosaurs. No other animal has that bone sort of in that shape. It's called the pteroid bone.
Really? It is completely unique?
Yep.
Wow. Okay.
And their wings are much more complex than you might think. You're probably thinking that it's just sort of like a bat's wing, which is just like skin, probably a bunch of blood vessels and stuff in it. And as far as I know, bat wings are not much more complicated than that, where it is just sort of skin. But pterosaurs were crazy. When you're stretching that skin, you know, bats can support it because they have 4 fingers running throughout their wing. That inherently just gives their wings some more support. Pterosaurs didn't have that.
More support, I assume, like more dexterity, or at least a different
Mm-hmm.
kind of dexterity when you have 4 fingers that are up there helping to control it.
Right, and being able to change that wing shape and how they need it.
Yes.
Pterosaurs didn't have that, so they had fibers running all through their wing to give it support and structure, and also muscles to be able to sort of change it in the way that they needed. It's also kind of thought that their wing might have just moved with air currents to be able to like so basically the equivalent of just like going with the flow. Like the wind flowing over their wings changed the shape of the wing to make it more efficient in flying. Something that
Huh.
birds don't really do. That insects tend to do that a lot. We think it's much harder to study insect wings than bird wings. Uh,
Why is that?
they're a lot smaller and more delicate.
Okay.
Plus, a bird you can kind of control. It is much harder to like get an insect to fly in the way and direction and time that you want it to.
I guess that makes sense.
Um, and then the craziest thing that I actually learned just like this past week in doing some of the research for this episode, is that we're pretty sure that pterosaurs had a space for an air sac inside their wing.
And what purpose would that serve? Is that like a buoyancy and air thing? Is that a breathing
Nope.
thing? Well, I have no
Nope,
idea. What is
that
this?
that wouldn't really change the way that of their buoyancy or anything. It is mostly for respiration.
Wow.
Also probably could have been used to do some kind of changing the wing shape like that again. Also, we think that it could have been inflated and maybe flushed with blood as sort of like an intimidation or maybe like a signaling thing to other members of its species. There are many birds that have like inflatable air sacs like on their chest or something. So again, that is all complete speculation. But we
Right. Of
have
course. I assume with all this, like it's hard to know for sure with any of this.
yes. Um, but well, we know there's strong evidence that at least certain species had this sort of air sac inside the wing, and sort of as we talked about with birds, with some of like the air sacs in their bones, how that is part of their breathing system. Um, because when you're flying, you just use energy much quicker than you would just kind of hanging out. So you need a really efficient breathing system. And we think that pterosaurs had a very similar breathing system that modern birds do, very similar.
Mm-hmm.
So that's sort of how the wings are set up. The rest of them doesn't get significantly less weird. They're really known for having really large heads and really long necks. Uh,
Large head, long like so. How are we talking in relation to the rest of their body, or in absolute terms? How big are we talking?
Um, and they kind of came in all shapes and sizes, but in general, the neck and head were probably each at least as long as the body, if not longer. Most of them were probably longer.
Wow. I just finally pulled up some Google images of these guys, and wow, these are some strange looking
They're
dudes.
just very oddly shaped. There's
Yeah.
nothing else even approximating what they are like today, which is part of the problem. At least with dinosaurs, we have birds, which aren't a one-to-one comparison, but they certainly help. Uh, but we have absolutely nothing left. These pterosaurs left no descendants today, and they are there's nothing even closely convergent with them.
Yeah, there is not. I don't know. Someone took a pelican and really stretched it or something. Like I don't know. This is. I'm out.
They're also really well known for their head crests, especially some of the later species. Um, for example, there's one called Nyctosaurus, Nytco saurus, and
Nyctosaurus.
yep. So it is known for having a branching crest off of its head. So think of like a Y shape, where each of like the arms coming off the Y is longer than the rest of the animal. No, I like what were you using that for, guy? And
It's that seems like is that inefficient? Is it more efficient? Like I don't even.
for generally the if you see some really large exaggerated feature on an animal where you're like, I don't immediately know what you were probably using that for, it was
Hmm.
probably a sexual selection thing. So it's like
Ah,
showing off for the ladies and or men. Because as far as we know, I don't believe, at least that species, there was any sexual dimorphism. Meaning that males and females were looked different. Some
right.
species definitely did. We have clear evidence that they were males and females were different. That species in particular, I don't know. But they're very well known in general for their big ornate head crests. Um, they also are well known for having really tiny bodies, as we talked about, relative to like their head. They have these giant heads and super long necks, and then this tiny itty bitty little Cabbage Patch doll body.
When you say Cabbage Patch doll, like is that an approximate of their actual body size? Is it Cabbage Patch doll?
I mean, it depends. Some of the biggest ones, their torso is probably not all that different sized than like a human torso. Maybe a bit bigger. Not
Hmm.
all that much though, considering it has a wingspan of 35-ish feet and weighed
And that's
about
just the
500
largest
pounds.
ones.
Right, and those are just the largest ones. Um, so the largest ones, their body was not considerably larger than a human. Um, and something that's actually been really common in the last couple of years is we've been seeing more and more evidence of their bodies being covered with sort of like fuzz. They were kind of fluffy.
Hmm. We wouldn't quite. And again, it's hard to know for sure, but like we wouldn't quite say feathers.
That has been a real topic of discussion in the last probably 3 to 5 years
Really?
because there's been some evidence that some of them do look branching. Some of the little fuzzes
Mm-hmm.
do look branching, which is very characteristic of feathers. They were definitely not used in the same way that birds use feathers to fly. That was absolutely not what they were using it for. Um, Mostly just to keep warm. Um, and so, what that kind of implies, if they are feathers, that implies that the common ancestor between dinosaurs and pterosaurs had feathers, meaning that feathers is the default condition for all dinosaurs.
The default. So you
Which
would need to
which
have
it
some
is
reason.
not uncommon for things to lose things like that. Like think of how many there are many kinds of hairless mammals
Right.
that all lost the hair independently.
Mm-hmm.
So like some of the large dinosaurs having lost feathers wouldn't be, I wouldn't put it past them.
Mm-hmm.
But saying that okay, if I also should have mentioned this earlier, but dinosaurs are the closest cousins of pterosaurs. So like on the tree of life, they are branches that are right next to each other.
Right. Okay.
So if their common ancestor had feathers, that means that dinosaurs started out with feathers. The very earliest dinosaurs had not full feathers like you would see in a bird or even like the later dinosaurs, just like a fuzzy coating that would eventually become feathers.
And they would have had to evolve not to have that if they were going to if they're going to be featherless, they would have had to evolve not to have feathers, as opposed to starting off without feathers and then evolving to have them.
Right. And again, that is completely the jury is very much still out on that one.
But it's cool to think about. It's definitely, it is not what immediately comes to my mind when I think of, what a dinosaur would look like, but it's, you know, looking at the evolution and, hearing what's possible or hearing you explain it to me. Like that's wild and it makes total sense.
Yeah, I'm really excited to see where pterosaur research goes in the next couple of years.
As am
Um,
I, and I'm looking forward to you telling me all about it.
so moving further down the body to like their legs is the last sort of piece of anatomy that we'll talk about. Is the second part of why pterosaurs swooping down and taking away children is not correct. They could not do that. They could not pick things up with their feet. So
Hmm.
their feet were very much like our feet. They only had four toes, and they didn't have like a big toe and a bunch of smaller toes. They had similar sized toes, but they were plantigrade, meaning that like you walk, your entire foot is on the ground when you
Right?
walk, instead of like a cat where it's just sort of they're walking on their toes, or like a
Yes.
horse which walks on the very end of its toe like a ballerina.
Mm-hmm.
And so birds sort of do that, but the difference between bird feet and pterosaur feet is that birds have an opposable toe. They have three toes in the front and one swiveled around to the back, and that's why birds can perch on branches. That's why eagles can swoop down and snatch up a fish from a lake. Pterosaurs could not do that. They had feet for walking, so
Right.
they did.
They wouldn't be able to grab anything. It'd be like me trying to grab something with my foot.
Right, and it's like, could you pick up like a pen or something with your foot? Probably. Could you pick up a child with your foot? No. So, but every single piece of media that pterosaurs get put in, they're shown picking people up, and it's like, no.
Picking people up?
Well, yeah. So the most influential one from like my childhood was Jurassic Park 3.
Oh yes, 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 yes,
In
yes.
the scene where they're in, going down the river, the pterosaurs swoop down there in like the giant birdcage thing, swoop down, pick up, a whole person and just try to fly off with them. I'm like, no, not only A, could they physically not do that, that would be like a bird trying to pick up, a dumbbell. Like, no, it physically does not, it is not strong enough to do that.
Right.
Um, Pterosaurs are probably one of the most misrepresented, fossil groups in media of anything. At least like representation of dinosaurs has gotten a much better, showing much more of them with feathers, much
Mm-hmm.
more of them being like much more active predators. And the Jurassic Park franchise has done a great job, helping with that. At least the more active predator thing, not so much the feathers. Um,
Right.
but no one gets pterosaurs right ever.
Is there a reason for that? Is it just like it's cooler to show pterosaurs doing, picking things up with their feet, or
That's exactly what it is.
okay,
Um, so now that we sort of talked about their evolution or their anatomy, let's talk about how they got that anatomy with some of their evolution.
okay,
And so this might be a bit of a spoiler or a bit of review, I guess, from episode 21. But you might remember we don't know. The first time that we see something that we can put in the pterosaur group, it is a pterosaur. We're very positive it can fly. Um, it is not, you know, that similar to like the super later ones right before they went extinct, but it
Hmm.
very clearly has all the pterosaur features. It's got that pteroid bone, the unique one on their hand that helps support the wing. Everything that makes a pterosaur, it's got. We don't have any transitional stuff.
This does ring a bell where it was just, no pterosaur and then pterosaur. They're not like these slow evolution like you would normally expect.
Exactly. And there's quite a few reasons for this that we think. Number one is that we just might have not found it yet. That's always potentially, a thing.
Hmm.
Is that it's out there, we just haven't found it yet.
Right.
Um, Another is that similar to how I described bats as toothpicks wrapped in tissue paper in that episode,
Yes.
pterosaurs are not all that much more sturdy than a bat.
Really? Even though they're that much bigger?
Well, because the early ones weren't all that much bigger,
Ah, yes, yes, yes. Okay.
because their bones are very much like birds, where they are not truly hollow. They're like the same weight, but they're structured in a way that gives them more strength without making them heavier. And
Hmm.
doing that, they're very good at resisting the kinds of stresses that flying puts on them. They're very bad at resisting the kinds of stresses that being crushed puts on them, and being buried puts on them. Um,
Oh boy.
so pterosaurs in general, at least the early ones, don't have a great fossil record, just because they're small and they're fragile. So there are a couple of hypotheses about some of their potential closest relatives. There is one that I'd want to mention. It's an animal called Scleromochlus, which
Can you pronounce that again?
Scleromochlus.
Scleromochlus. I feel like sometimes you make these up.
Nope, that is a real thing. Um, it
Was.
is an archosaur, so it is in the same group of reptiles. So there's sort of two main branches of reptiles. There's the archosaurs, which are your crocodilians, pterosaurs, dinosaurs, including birds, and then your lepidosaurs, which are your lizards, snakes, most other things. Turtles go somewhere on one of those groups. We don't actually know. Um, but so this Scleromochlus thing was a an archosaur that had a couple of things in common with pterosaurs, and that's kind of the best we got.
Okay.
So, and it was around at the same when it should be around for being closely related to their ancestors. So, like the timing works.
Right.
Not really sure um, about like it's probably not. It's the actual ancestor of the group Pterosauria, but it's probably close,
Close enough.
right? And then boom, we got them. Um, So the earliest pterosaurs that we have are all from Europe and Greenland. They're all from the same part of the world, unlike some other things that kind of show up globally at around the same time. Pterosaurs appear pretty localized, at least at the beginning.
Localized where?
Like I said, like Northern Europe and Greenland.
Okay.
And so that has kind of led to the hypothesis that that's probably where they evolved, or at least where the first ones showed up. And
Hmm.
then they very quickly spread, which sort of leads me to talking about something really interesting that I've kind of started calling predictive paleontology, because a lot of things in paleontology are just describing uh, things. You find a new fossil, you describe it. There's a lot more, biomechanics type stuff, but that is historically what paleontology has been a lot of. Predictive paleontology is sort of like, okay, so this type of fossil should, you know, is from around this time, or saying, okay, the ancestor to pterosaurs should be around the early to middle Triassic, maybe around 235, 240 million years ago. And we're pretty sure they evolved in Northern Europe. Let's go look at a map and see where we find those age rocks in Northern Europe and see what we can find. And there's actually a precedent for that working. There is probably like the most definitive fossil of a transition from uh, the water to animals first coming on land, or vertebrates first coming on land, as a fossil called Tiktaalik, which the people who found that were like, okay, it should be around Middle Devonian. where do we find those rocks in the northern hemisphere? And they were like, okay, Canada, cool. They went to Canada and they found it. And they described it where it should be. So there is precedent sort of for them being like, okay, these pterosaurs should be in Northern Europe around this time. Let's go find some of those rocks and see what we can find.
So basically, this is just taking what we already know and saying we should be able to find these types of fossils in this area if we know what we're looking for, and then going out and then hopefully, finding them and proving yourself. You'd be like, yes, this makes sense. We have found what we were looking for.
Exactly. So that's basically all that we have about their evolution. I'm not really going to talk too much more about it because I want to get into some of the cooler stuff. So there are two
I'm in.
general groups of pterosaurs. They're called the pterodactyloids. You can guess some of the things that are included in that group. And then
Yes.
historically, the other one has been called the rhamphorhynchoids. That is generally not a term that's used anymore. So I think I've talked before about monophyletic groups on the podcast. Does that phrase ring a bell?
It does ring a bell. You're gonna have to refresh my memory.
Sure. So basically, if you pick two animals and you make a group out of them, including those two and their most recent common ancestor. So
Mm-hmm.
for if you make a group containing humans and orangutans, including their most recent common ancestor, that group must also include gorillas and chimps, because they are also descendants of that most recent common ancestor.
That makes sense.
So you have to include everything, which is why birds are reptiles, because you can't make a reptile group that doesn't include birds.
And as we discussed, this is part of the reason why reptiles is a bit problematic of a term.
Right. So the reason why this monophyletic group problem kind of comes in with the pterosaurs is that the rhamphorhynchoids are not a monophyletic group. It is just sort of, okay, everything that's not a pterodactyloid is called a rhamphorhynchoid. So it is not a proper group. The more proper way of saying it would be just non-pterodactyloid pterosaurs.
I was gonna say this seems like a definition based on exclusion rather than any actual defining characteristics.
Exactly, which is why we don't like it. So from here on out, basically the early ones, I will be calling rhamphorhynchoids just for simplicity's sake, and because that's how you will often see it.
Right.
But just know that that is not the proper way to actually do it.
Okay.
So first we'll talk about the rhamphorhynchoids because they're less interesting. They're still neat, but they're less interesting in my opinion. So
Right.
these are the ones that you generally see that are generally pretty smaller, have larger heads and shorter necks. They're known quite often for having pretty large teeth, and also have long tails. So if you see a pterosaur drawn or in a movie or something that has a long tail, sometimes with like the little diamond shape at the end, sort of like a devil or something, that is one of these early pterosaurs in the quote unquote rhamphorhynchoid group.
Yes.
So some of the more common or more noteworthy ones are called Dimorphodon, which, even for a pterosaur, has a very large head relative to its body. Its head is very large. If you've seen Jurassic World, the first one with Chris Pratt, there are two pterosaurs that you see flying around. This is the one that has teeth. The one that you see like that, like, one of them like tackles Chris Pratt and like tries to snap at him and stuff, and he's like wrestling with it on the ground, even though it would weigh like 10 pounds. That is supposed to be Dimorphodon. Not the best depiction of it in media, but that's what it is.
We got what we got.
Exactly. So it was pretty decently sized. Its wingspan was about 4.5 feet. So a good sized bird. That's a very noticeable bird. If you see a bird with a wingspan of 4.5 feet, you're like, oh, that's a pretty good sized bird. That's like several different well-known hawks are around that size.
Right.
And the other well-known one is the one who sort of gets the group Rhamphorhynchoid gets its name from, which is Rhamphorhynchus, which also is well known for having its teeth. It's got a much pointier sort of skull than Dimorphodon does, which Dimorphodon is much more rounded skull. Rhamphorhynchus is a little bigger, wingspan about 6.5 feet, about bald eagle size. And this one is one that's very well known for having the like sort of spade shaped thing at the end of its tail. And basically all pterosaurs are depicted with that now because of this one. Even ones that had long tails but didn't have the thing at the end. So,
This was just, it was cooler looking, and so people
yep,
went with
exactly. Which is why this group never gets depicted correctly in media.
it.
So then we get to the pterodactyloids. It is the larger group and the group that you're probably thinking of when you're thinking of a pterosaur. They have
Hmm.
generally beaks instead of large teeth. These are the ones that are well known for having those really big head crests and generally just much, much larger.
Right.
So the first one we're going to talk about is Pterodactylus, the one, the famous one. And it's not even like sort of the most well known pterodactyl, or even really that large. Pterodactylus was actually rather small. Its wingspan was only about a meter, so a little over 3 feet.
Really?
Yeah,
That is
mm-hmm.
that is
Pterodactylus was
some
not
weak
that large.
stuff.
Which, like, again, a bird with a wingspan of 3 feet, you'd notice it if it just kind of landed in your yard. You'd be like, "Wow, that's a pretty big bird. What are you doing here?"
Yeah, but there's difference between, the crow that lands in the backyard versus what I'm thinking of, a
A giraffe.
pterodactylus. Yeah, right. Yeah.
um, Probably the most well known, both in media and also fossil wise. This is the one that by far we have the most fossils of. Is called Pteranodon.
Pteranodon, okay.
This is the one that is depicted in Jurassic Park 3 that grabs the people. It is only slightly bigger than it probably was.
Say that
Mm,
again?
I guess, sort of thinking about it, that's not quite true. It was very large. Not nearly as large. It was definitely smaller than they showed it in the movie,
Okay.
but not like noticeably so. Its
Okay.
wingspan was about 5.5 meters, around 20 feet.
So they took some artistic liberties, but like weren't totally off base.
Weren't totally off. What they did do excellently in that movie is actually depict how pterosaurs walk. That
Which
is
is
on all fours. We'll, t- we'll,
okay.
we'll talk about that in a little bit. Spoilers. But so we're sort of highlighting some of the well-known pterosaurs here.
Yes.
But again, 20 feet. That would comfortably be the largest flying animal on the planet today if it were alive.
What is the largest flying animal on the planet today?
By wingspan, it is the wandering albatross, which has a wingspan of about 11 feet.
Okay.
So comfortably being like almost double that.
Yeah, that's not even close.
Um, yeah, and that's only like a medium large sort of size pterosaur. We have going up the scale here one called Hatzegopteryx, which has a wingspan of about 10 meters or about 33 feet. And the reason that I love Hatzegopteryx is actually, I'm going to do a little foreshadowing. We'll talk about why I love Hatzegopteryx so much in a little bit.
Is it the name?
Yes, but it gets its name from a very particular from the place that it lived.
Okay.
But from what we can tell, the largest pterosaur is one called Quetzalcoatlus, famously named after the Aztec, I believe it's Aztec, god. It's a feathery serpent flying god.
I wasn't gonna say anything because I thought it was just a coincidence or I was
Nope.
misremembering, but okay, like Quetzalcoatl.
It is called that deity is named Quetzalcoatl.
Gotcha. Okay.
And so this one is called Quetzalcoatlus. There are most estimates that you'll see will put its wingspan at about 11 meters or about 35 feet. There have been some that estimate it to be a bit bigger at about 13 meters or 43 or so feet.
That's just not right. That is.
That is small airplane sized. I have been in a plane with a smaller wingspan than that.
How did you feel being in that plane?
I was afraid. So these are absolutely gargantuan animals.
Could they? Well, I was actually about to ask a very stupid question, and we're gonna laugh at me for almost asking a stupid question. So if you didn't listen early in the podcast, you would be forgiven for thinking this was okay. I was about to ask, would they be able to pick up a human? We know that they can't pick anything up. So moving on with that.
No, they definitely could not. But
Yeah.
something that has been not so much these days, but in the past has been argued, could these giant ones even fly? Because
Hmm.
as we talked about in the flight episode, birds have lost their flight many times. Birds will lose the ability to fly on a whim, seemingly, because it is very cost inefficient. Like there are many benefits to flying, but if you don't have to, why would you?
Right.
And so it's like, okay, were these just the ostrich, giant flightless thing of pterosaurs? And the answer is probably no. We're quite confident that these actually could fly. And the main reason is for how they took off, which is absolutely incredible. I talked about it a bit in the flight episode, but I want to reiterate it because it's crazy. They only figured this out probably in the last couple of years.
Let's do it.
So birds, and so the reason that I know that this next part kind of blew your mind a bit, I listened back to the episode in preparation for this episode.
Hmm.
But so birds, when they take off, they jump. Birds have really big, meaty drumstick, legs
Hmm.
to be able to jump off the ground and then fly. Pterosaurs did not. Their legs were relatively quite small, and even with the big ones, it's not like their legs got proportionately bigger like you would expect a bird's legs to, as with the really largest birds.
Right.
Instead, and we will link an article from Scientific American that has an excellent figure in it that shows how they took off. But they basically Hulk smashed their way into the air, is how it has been described to me. Where that's a bit of an exaggeration.
Even if it's an exaggeration, it's still cool to think about.
So, like I mentioned, they're walkers. They are walked on all fours, and so what they would do is they would essentially sort of pretty much just lean forward until their legs lifted off the ground, and then do a super push up and launch themselves into the air. And so they could basically take off on a dime. They didn't need a run up like even some birds today do. Like, have you ever seen like a duck or a goose take off from the water? They need a good run up before they can actually get into the air.
Right, right, right.
Albatrosses, the at least largest wingspan flying bird today, they also need a bit of a runway to get into the air. These just didn't. They could just slam their hands into the ground and do a super push
Hmm.
up and fly away. And there's
Lean
even
forward, push up, and they're good. That's
mhm. And there's even some speculation that they couldn't really sit on the water like a duck does, but they probably could have rested sort of on the water, some of them. And based on the physics and the math, they probably could have done that in the water too. Just Hulk
wait,
smash the
wait.
water and launch themselves into the air. That's how crazy these animals were.
On the are these things like Jesus? Like what?
Well, I mean, birds float.
I get it, but being able to push yourself off the water as a means to achieve flight,
Again,
like water's not
that
solid.
that one I don't know. I did not read the physics behind that because I frankly would not be able to understand it. But
It is
that
not
is
impossible that was a thing that happened.
yes,
Wow. All right, good enough for me for just to say that's nuts.
which is part of why we think they were able to get so big was because birds, you know, to get themselves into the air need to add muscle to their legs and then need to add more muscle to their flying muscles to be able to then push their now beefy legs through the air. But with pterosaurs, it's like, okay, the flying muscles and the launch muscles are the same muscles. So you can just make those muscles big, and they help out on the ground and in the air. Whereas birds, it's like, okay, the muscles for the ground don't really do much while you're in the air.
It's less efficient to do it the way that modern birds do.
Exactly. At least when it comes to takeoff like that. So that's
Right.
why we think pterosaurs were able to get so big and still be able to fly.
Right.
So let's talk about some things that they did. Some things that they, we talked about some different kinds of them, some of their anatomy, but what did they actually do? Because, like I said, they were around for a very, very long time and did a huge variety of things. Just like birds, there are lots of birds that do different things. There are things like eagles that are predators. There are things like pelicans that like skim the water. Things that eat seeds, like little finches.
Right.
Pterosaurs, we have a very limited number of fossils. Like I said, we have only about 100 different species compared to like the 10,000 or so species of birds that we have.
Okay.
So obviously we're getting a much diminished sense of what they actually could do. But these are some highlights. Stereotypically, they're often depicted as eating fish, which kind of makes sense because most of them are found in sort of marine or water-based sediments. So they tend to live in places with lots of water. So that's
Is
just
the
kind
eating
of
fish, is that a solid assumption
for
because of
for
that?
for some of them, for quite a few of them.
Okay.
Some of the ones with like the really big sharp teeth, those are very stereotypical of what you would see for things that eat fish.
Mm-hmm.
So some definitely did. Others, not so much. There is one called Pterodastro that had arguably no teeth, but instead had sometimes up to 1,000 bristles on its lower jaw that were like, are those teeth or are those something else? As far as I know, we think that they're teeth, but up to 1,000 of them in their mouth. And there's really only one thing that that's good for, and that would be filter feeding.
It's like krill.
Krill.
Wow.
Basically, they were a flamingo. Their beak is even so. Flamingos, their beak curves down. Pterodastro's curves up, not nearly as sharply, but it does curve up like that,
Uh-huh.
which has led to a lot of fun speculation. It's like, okay, was Pterodastro pink? Because
Well,
flamingos are born white. They turn pink because so much of their food is red and has that red pigment. That is why they are white, or why
oh,
they are pink. Their feathers are not actually pink.
I see where this is going.
So it's like, okay, um, if this was all it was eating, did its fuzz or even its skin? Who knows? If you ate a diet of nothing but carrots, you would turn kind of orangey yellow. So
Patreon goal.
I'd be so malnourished. But yeah, so there's
But worth it.
been some fun speculation that Pterodastro might have been pink because of
That
this.
seems to be semi well found. Like,
Right. And like there's no way we will ever prove that.
right.
But it is very fun to think about. Circling back to Hatzegopteryx, one of the super, super large ones. So it is found in Romania on what used to be an island called Hatzag Island. At the time when this thing was alive, that was an island there. We have lots of evidence, and it's an area well known for having dwarf species of like dinosaurs and things from around the same time, which is very common, as we sort of talked about in the elephants episode. When big things get to an island, they tend to get very small very quickly.
Right.
So there's dwarf sauropods, the long neck dinosaurs, and like a dwarf sauropod is still like 6 feet tall at the shoulder or so, so it's still a big animal. But there's noticeably not any really large predators that we could find on that paleo island until we found
Hmm.
this thing.
Okay.
And so we kind of think that this pterosaur, which again would be about the size of a giraffe when it's on the ground, was the apex predator on this island. Just snapping up little pygmy dinosaurs.
And roughly how big was this guy? Or probably, how big was the island?
I mean, it was a fairly good sized island. I don't know off the top of my head, but
Okay.
it was, not just like, a little tiny island with like one palm tree on it.
Right. Okay.
So it had enough, it was big enough to support a dwarf population
Yes.
of, several different kinds of dinosaurs. So it's a sizable island. And this thing likely was the main large predator on the island.
Okay.
The weird thing, I think the weirdest pterosaur that I was able to find, at least in terms of its lifestyle, was a relatively new one that was discovered. And I'm going to butcher this, but I believe it's called Leozipteryx or Leozipterus.
Leozipterus. Okay.
And it had a very special hyoid bone. And the hyoid bone is what anchors your tongue muscles in the way back of your throat. And its hyoid bone was very similar in shape to that of a chameleon. And chameleons are very,
Okay.
very famous for doing one particular thing with their tongue:
Catching flies?
shooting it out of their mouth like a grappling hook and catching things.
Yes. Okay.
So
So is that real? Like, what? Like,
we don't
did cartoons
know.
lie to me?
Yes, with chameleons, that is absolutely a real thing.
Okay.
And again, we don't know this for sure, but its hyoid bone looks very similar to a chameleon's, meaning that its tongue might have been similar shaped and had similar musculature. It might have been able to shoot its tongue out.
Might have been able to do the same thing.
Mm-hmm. Potentially, while in the air, while flying around, could have just chameleoned and just snatched bugs out of the air while it was flying.
That'd be a sight to see.
There's also been lots of proposals. You'll see this very commonly in some documentaries. Some of the smaller ones, some of the earlier ones that weren't really all that big, that were sort of filling the same ecological roles like an oxpecker. Birds that live in like the savanna of Africa that sort of have a symbiotic relationship with rhinos and ox and things like that, where
Hmm.
they live on the back of them and eat off all the bugs and parasites and things from the big animals, and in turn the little bird gets protection from anything that would want to eat it.
Right.
There's been some proposals that some of the smaller early ones did that with some of the big sauropods, where they would just kind of live in a colony on their back and eat the bugs and things off of them.
Okay.
So these are an incredibly varied group of animals, not just big, scary monster that lifts people off the ground.
Yes. There's quite a bit of diversity in this group.
Exactly. And so one last thing I want to touch on is something that also, up until relatively recently, we didn't really know how it worked, and still kind of don't. But that would be their breeding.
If we were a higher end podcast, there'd be some swanky music that would start playing right now.
Maybe in the future.
Patreon goal.
um, so, based on the things that we have around today that fly, which are, birds and bats, they both have pretty extreme parental care. Bats, are mammals and therefore need milk when they are babies, and their mom takes care of them. And birds are,
Hmm.
obviously very famous for taking care of their eggs. We kind of didn't know. Okay, well, it's like, can they fly straight out the egg? Or are they just kind of stuck on their own for a while until they learn how to fly? Or do mom or dad take care of them? And generally, we don't know. We have many pterosaur eggs, particularly we found excellent nest. And I say we as in science, not me, obviously.
Hmm.
Um, Found what has been interpreted to be a nesting site, like one that was returned to year after year for a very long time. Hundreds and hundreds of eggs in different layers of sediment. So it's not like a big flood came in and washed away all the nests. Consistently for probably thousands and thousands of years. Lots and lots of good egg fossils with some fossilized embryos. And from that, we're pretty sure they couldn't fly straight out of the egg, but we do know that they grew very quickly in their early life. You know, as do a lot of warm-blooded animals, which these have been interpreted to be. Um, but they probably couldn't fly. As for whether mom and dad were around when they hatched, we don't really know.
So they probably were able to learn to fly pretty quickly. Maybe not, like at the moment of birth, but shortly thereafter.
Right. And that could also kind of explain why they're so good at walking, is because, maybe for the first year, 6 months of their life, they couldn't fly. So they had to walk around in order to get their food.
Right.
So that is pterosaurs. And while that might not have beaten the elephant episode, but
I mean, so here's the thing. No, it didn't. But like, you are hitting gold on just weird animals. Even just, again, just Googling
I
these
will
guys.
not run out, I promise you.
Oh, I know you won't. But just the way these guys look and they, they're represented wrong in movies and they might have been pink and they're like all of this. It is, it really, and they're so diverse, this particular group, pterosaurs. It's, it, I don't think anything will ever beat that episode, that elephant episode for me. This is just another example of just nature is wild.
Oh, I'm gonna try. I've got a couple in mind that might do it. We'll have to see.
I am greatly looking forward to when we get there. However, this has been episode 29 of I Wish You Were Dead, a podcast about things that used to be alive. This has been the pterosaur episode, and I'll make sure I get that right in the title of this episode. Gavin, thank you very much, and I will talk to you once again next week.
Absolutely, Mike. Thank you.